God bless you, I mean, oops.
Okay. What does a solution of a system of equations mean? What does a solution of a system of inequalities mean? How are they similar or different? About 30 seconds, and I'm going to scroll that down. Okay, we're going to skip this first one, so don't worry about going with the pictures. We're going to do this one down here on the bottom first. So, right, this is example 1. Again, this is probably going to take 2 days to get through all of it. What are the solutions for the system? Solved by graphing. How many equations do we have? 2. So a system is multiple equations equal the same variable. So essentially I can even scribble out, put y equals, and then put a, that's a real ugly base. Let me try that again. Really good. A white pencil. Aha, erase this. And do a squiggly base like that. I took out the double y equals and put 1 y equals a system, meaning y equals, creates 2 different functions. X squared minus x minus 2, and negative x, y also equals negative x plus 2. So, what we're going to do is solve this by graphing, which means we need to do some graphs. Okay, we're going to set up an XY table. I'm going to show you a shortcut on your calculator. Okay, if you need help drawing a straight line, you may use the edge of your calculator lid. You take the lid off your calculator, right there, straight line. For X and Y. Now when we're looking for a solution, the first equation, can anyone tell me what type of graph the first equation will look like? Put that away. The first equation, y equals x squared minus x minus 2. What would that graph look like? It'd be what? Concave, because, it's a quadratic. So it looks like a parabola U, yeah? What does the second equation look like? It's linear. Next to the first power is a line, right? So a solution is a point where these two cross, because they are equal on each other when they cross or intersect. So right now we don't really know where that's going to be. So I'm going to do a large window from -4 all the way down to +4. So hopefully that's wide enough that I can actually see where they intersect. -4, I'm going to look at my x's all the way down to +4. Let's go. Okay, I'm going to show you a shortcut on your calculator to get these points faster. Everyone have your calculator? So turn it on, and then we'll find the y equals button. Right here, top left button, push y equals. Does anything in there? Clear it out, please. I need the y equals 1 equal sign to be highlighted. As I type in x squared, it automatically highlights. I don't want the y2 highlighted. So if you have one of mine that was used earlier today, you need to unhighlight the y2. You do that by arrowing over to the highlight or to the equal sign and pressing enter. It will highlight it and unhighlight it. So y1, I want to type in x squared minus x minus 2. Oh, in the screen, I might as well type in y2, which is negative x plus 2. But see how both are highlighted right now? I only want to look at the y1. So I'm going to arrow over on y2's equal sign. Make sure my flashing cursor is on the y2's equal sign. If I push enter, it will deselect it. So I only have y1 highlighted right now. Look above the graph button. What does it say in yellow or in blue, depending which calculator you have? Table. Isn't that what we're making? It's a table of values. So let's go second table. And if I have deselected y2, I should only see 2 columns. If I have both selected, I'm going to see 3 columns. I right now only want to look at 2 columns. And I want them from negative 4 to positive 4. Just come over here to your chart and fill them in. Captain, what should I plug in on negative 4? If that's the negative 4, y is 18. Good. Thomas, negative 3. 10. Dejan, negative 2. Yeah, negative 1. Good. We all see it, don't we? Sorry, all of it. Okay. 0, negative 2. Ooh! Look right here. Do we have a repeat? That tells me the vertex is sandwiched between the repeats. So if 0 and 1 are the repeat, what's sandwiched between 0 and 1? Put it in the middle. 0.5. The vertex is at 0.5 for the x. Then we get 2, 0. I can't see the rest. But we should have repeats, shouldn't we? 0. Starting for difference would be 4. That would be 10. Okay? If you want to take a different color, if you're going to do that one in regular pencil, take a different color. Maybe I should look at my wife. The first line is y1. This one I'm going to do as y2. So I'm going to do another column on my same chart in a different color, so I'm color-coded. The first one was y1, the second one in a different color is going to be y2. So we've already typed it in, we just need to go select it. So if you go back to the y equals button on your calculator, hit y equals, how do I unselect y1 and re-select y2? Enter on what? The equal sign. So here I'm going to deselect y1, so press enter and it's no longer selected. Go down to y2 on the equal sign, press enter and only y2 is selected. Then I can go second table. So you want to have questions on what I did here? I go second table, and now I only see the x values, and the middle column I have on the board is hidden, and y2 is showing. So again, we need these from negative 4 to positive 4. So negative 4 is 6, you can just write them down. 5, oh, this is interesting. Why is it like this? 6, 5, 4, 3, 2, 1. How can this go in order like that? It's linear. So obviously we have a descending slope with negative 1. 0, so negative 1, negative 2. I don't have to see it on my calculator screen. Okay, we have points. Now we're going to go graph them using different colors so we can make sure we know which is which. So again, if you need help drawing a straight line on your grid paper, you can use the edge of your calculator or the edge of another piece of paper. Let's look, before you draw a graph, analyze your data. Do we have any negatives? that they're really small. What's our lowest negative? -2. We don't have to go all the way to -10. Too much. Only -2. What's our highest positive? 18 on the y's, right? So let's make a graph. And we have to have more in the positive direction than in the negative direction. Do we have to always count by 1? Do we want to do 18 lines? No. We can make each of your boxes on your graph paper equal to how much? 2. I think 2 is acceptable because then we're still doing enough lines. We have almost 10 lines. So that if you're willing to count by 2, you must tell me you're counting by 2. So that's what we label, 2. So each one of your boxes is going to represent an even number. 2, 4, 6, 8, 10, 2, 4, 6, 8. So now we are 18. And -2. If y is counting by 2s, does x have to count by 2s? X does not have to count by 2s. It can count by its own scaling. Since we only have a couple numbers, from -4 to +4, the spread's pretty small. I'm just going to count by 1s, but again, you must label it. And then take whatever color you did y1 in, and we're going to plot those points. We already talked about how y1 should be a quadratic function. So when we plot these points, it should look like a parabola. -4, 8, oops, a little high, 18, -3, 10, -2, 4, -1, 0, 0, -2, 1, -2, 2, 0. And I start seeing it come up, back up, so that's a good thing. And I see symmetry. Let me stop at 4, comma 10. So you want to know the y value for x equaling 5. 18, because of symmetry, right? Okay, but that's enough right there. So, and then after you plot the points, make sure your points are large enough so that when you draw your parabola through them, you can still see the points. It should be curved. This one's kind of an ugly looking parabola. But it should be curved at the bottom, not angular. It doesn't look like a V. Drawn your parabola, take your second color. If you haven't color coded, you might want to take that color and shade this column. So I saw some people just do it all in pencil. So we need a color code of some form. Mine's already color coded in green, so I'm going to do this one in green. I'm just going to ignore the middle column. So my first point is -4, 6. So I just ignore the middle column. I get -4, 6. And plot. This one we discussed already should look linear, which is a line. -3, 5. Just ignore the middle column. Ooh, -5 is between, excuse me, +5 is between 6 and 4. -2, 4. Ooh, what happened here? What happens here? They intersect. So what is this called right here? It starts with an S. Solution, which is what we're trying to find. A solution is where they are equal to each other. Graphically, that's where they intersect. Okay, and then it just keeps stepping down by 1 each time. Ooh, another one. There's another one right there. Does that look linear? Yeah, I think it is. on forever. So the solutions. It kind of depends how it's asked. If it asks you for the points, we could write them as two-ordered pairs, but mostly we just want the x when are the x's the same. Okay, so Annie, what's the first ordered pair for one of the solutions? The point, the x comma y. -2, 4. Good. Anthony, what's the next ordered pair? Annie did the -2, 4, because that's where they intersect. What's the other one? Comma. What's the y value of this point? 2, 0. Okay? Generally, when we solve for the solution, so we just write x equals -2 and +2. Okay? Any questions on that? So we solve graphically. So graph them and we found where they intersect. Okay, we're going to try to start this next one. Does anyone still need this? Okay, you don't have to write this next one down word for word, but you should write down the important information, just like you do your homework. There's supposed to be 3 steps. Write the problem down or story problem line that means important information. Show your work, box of your answer. So, raise your hand when you see something important as we move along. Since opening day attendance at Pool A has increased steadily, while attendance at Pool B rose and then fell. Thomas, just say your hand real quick. What? Why do we know it's linear? Steady. Linear. Excellent. Observation. What about Pool B? Is it linear? It's quadratic. Because it rose and then it fell. And it didn't say anything about rising constantly. It just went up and then it fell. So it's actually a negative quadratic, right? Equations modeling the daily attendance y. Other times, know what y is? Yeah, so this is something you should write down. Daily attendance y. At each floor shown below, where x is the number of days since opening day. I don't see any hands. Is that important? We need to know what the variables are, right? So x is the number of days opened. You can just abbreviate it. The number of days opened. On what days was the attendance the same at both pools? Okay, at what day are the attendance the same? So, that would mean both graphs, if the attendance is the same, what's happening to both graphs? They're intersecting. We know Pool B looks something like this. Pool A looks something like this. And at some point, they are the same. So we're going to do a different model here to solve this one. Okay, and instead of doing it graphically, number one, because we're almost out of time, if they're the same, doesn't that mean that both have the same y value and x value right here? So their y's are exactly the same, or equal. So can't I just take the y's from Pool A, y equals this, oops, maybe with this, Can't I just take 28x plus 4 and equal it to the version of Pool B? What is b equal to the same y? Negative x squared plus 9x plus 64. That's what's called substitution. Now we're going to solve for x. But since this is a quadratic, how do we solve for x with quadratics? How's the easy way? Then it's easy, right? Remember that? How How's it easy? What's equal to? 0, then it's easy. Because we want their differences to be 0, right? We want them at the same point. Make sure it's set equal to 0. So, oops, actually, you know what's actually easier? If this guy's positive. So since it's negative, I'm going to choose to move everything to the left. Plus x squared minus 39x. So that cancels and that cancels. Minus 64. So that the right hand side is 0. So x squared. How many x's do we get? Negative 11x minus 60. Okay, what's one way, and it's a nice quadratic, what's the nice way, the easiest way to solve a quadratic, if it's a nice one? Tic-tac-toe. So let's see here. Let's see if it's a nice one. Maybe, may not. 1 times negative 60, and we have to add to how much? Negative 11. Can you think of two numbers that multiply to negative 60 and add to negative 11? Ooh, I think that might work actually. Negative 15 and 4, does that work? Yeah, good, because I really Googled it right off the bat. Good job, Thomas. Negative 15 and 4. Who are your x's? Let's get our binomials. Okay, shout it out. Zoom so time. 1, negative 15, GCF. 1 and 4, GCF. 1, negative 16, negative 15. Negative 15 because they're both negative, so they have negative in common. Negative 16, 4. 4, make sure it works. 1 times 4 is positive, positive, negative. It works. So, my binomials, x plus 4 times x minus 15 equals 0. How do we solve when we have the factors? 0 properties, we do a squiggly line. Take x plus 4 and set it equal to 0. So x equals negative 4. And this one, x minus 15 equals 0. So x equals positive 15. One of these answers makes sense, one does not. X is the number of days opened. Which one does not make sense? That was before they were open. So of course they have the same number of people. They don't have 0 people show up before they were open, right? So our answer would be, on what days is the attendance the same? So on day 15, pool A and pool B have the same attendance. Okay, since we're not finishing this today, you're not going to have any homework on this. Your only homework is progress report signed, and a lot of you already have makeup work from that. There's only 3 assignments on it. And what is due next time? Complete the square. Okay, you can leave your color pencils on your row, put them in the box, and leave them on your row. Now grab them for you. Please bring those 2 pieces of graph paper back next time. Yes, what was your score on that?